Hi, today we're going to take a look at using graphing calculator technology to help us achieve our goal, to write an equation that models the data. This is really getting at the heart of linear regression, our Unit 2 topic. So here's just an example of a scatter plot that we may have come up with over the last couple of weeks. We can recognize here that we have a positive trend as our data is increasing as we move across from left to right. So the higher the x values, the higher the y values. So our goal again is to write an equation that models this data. So we're going to try to come up with a line, like our trend line or line of best fit, and then find the slope of that line and the y-intercept of that line to be able to write our equation. So here's how we do that using a graphing technology called Desmos. So you're going to want to go to www.desmos.com, and I would recommend bookmarking this page. When you get there, you'll see this message right in the middle of the screen, and you can just click Graphing Calculator, and it will take you to the Graphing Calculator. Once you're there, you'll see on the left-hand side of your screen a bunch of empty blanks where you can enter in regular math problems or you can type in equations for graphing purposes. And then in the upper left-hand corner, you'll see a plus sign. That's the Add Item button. So you click on that to insert an item, and you'll get a drop-down menu. We want to choose Table, because what we're going to do is we're going to enter our data for the scatter plot into a table form so the graphing calculator can take the exact data. So you click Table, then you start typing in your entries, putting your x values on the left and your y values on the right. Make sure that your entries match and that you have an equal number of x's and y's, or it won't work nicely. After you've graphed, you might see your data in the table, but if your data is numbers in the hundreds or even thousands, you're not going to see it from your standard window screen. So there's a little magnifying glass with a plus sign in it on the left-hand side of your screen. It's actually going to be more in line over here with your table, kind of at the bottom of your table. But you're going to find this little magnifying glass and you're going to want to click on that. And what it's going to do is it's going to change your graphing screen so that your data is centered on your screen. Now you'll have to keep in mind that your X and Y axes will look very different when you do this, as it zooms in on just a picture of the data and not keeping the origin at the center of your screen. But when you do this, you can describe the correlation of the data. For example, in this data, I can see that my correlation is negative. There's definitely a negative trend here. It's actually pretty strong too, by the looks of things. So a strong negative correlation. All right, so we're going to go ahead and take a look at an example. What I have here is some data from the 2019 World Series Game 5, where 8 different pitchers were used during the game. We were recording the number of strikes that that pitcher threw compared to the total number of pitches that that pitcher threw. So obviously the ones that weren't strikes were balls. And we are going to use the technology to make a scatter plot to describe the correlation and to estimate an R value, which is our correlation coefficient from last week. So first thing I need to do is go to desmos.com. I'm going to kind of pull this off to the side. I hit Graphing Calculator. And here's where we have the graphing screen on the right and the entry screen on the left. If I wanted to just do basic math, I could type in things like 4 plus 5 equals 9. 5 times 7 equals 35. 3 parentheses 4 minus 6 parentheses equals -6. So I can do stuff like that. If I want to get rid of that, I just hit the X, or I can go to, I believe it's delete all. There we go. It clears everything. But I want to enter my data into a table. So I have to hit Add Item, choose Table, and now it'll build a table in my first calculator window. So I'm just going to go in order. So my X's are on the left, my Y's are on the right. I type in 71 strikes, 110 pitches, 15 strikes for 16 pitches, 11 strikes for 13 pitches. I'm using the Tab key to just move. It just moves across the row and then down to the beginning of the next row. So 48 strikes, I hit a tab, 78 pitches. When I hit tab again, it brings me down to the beginning of the next row. So it actually makes it quite easy and quick to type in my data. And that last pitcher did really well. Only had to throw 2 pitches, got 2 strikes, probably only faced 1 batter to get 1 out. Now, when I do that, I can see that my data is kind of all over the place. I could see a dot here, and it looked like there's some other dots up there because my origin's centered. If I want to see where my data is and center my actual data, I hit the magnifying glass here. Notice how it rezooms everything. So now I can see a little bit better, and I actually see the origin here. My y-axis is the number of pitches, my x-axis is the number of strikes, and I can see a definite positive trend. Okay, that the more strikes are thrown, the more pitches were thrown, and I guess that makes sense because you have to throw more pitches to get more strikes. All right, so that's the first part. Let's go back and take a look at our questions. What were we supposed to do with this? Make a scatter plot, which we did. Describe the correlation. It is a strong positive correlation based on what I'm seeing. And estimate an R value. Well, if it's a strong positive correlation, I would say the R value would probably be around, remember it has to be, between 0 and 1, so 0 point something. And the stronger the correlation, the closer to 1 it is. So I'm going to say about 0.95 because I thought it looked pretty good. I'm going to go back to it for a second, full screen. I think it looks like things line up pretty nicely. There's a little up and down at the beginning, but in the grand scheme of things, when I draw my line of fit here, they're not that far away from the line. It's a pretty good fit. All right, so then how do we find the actual R value? How do we get the line of fit to appear on our data? And how do we get the slope and the y-intercept of the line? That's the next step. So here's our third step. Find the exact line of best fit. Okay, find the exact line of best fit. So in Desmos, we are going to type this exact code. This is like think of it as computer programming code that you have to type this in to get what you want out of it. So this equation, it can be kind of confusing, but here's what you're looking at. It models something we know. We know y equals mx plus b very well. But it's specific, not just x and y, it's x1 and y1. It's a very specific set of data on the table that it wants us to use. Because if I go back here for a second, notice in my table, it's not just x and y, it's x1 and y1. So when I type my equation, it's going to pull from that, y equals mx plus b. So I can kind of start with that, but I want to make it specific. y1 means it's from the table, and x1 is from the table. And you'd be like, whoa, where'd my data go? My table's gone. And that's because I have an equals there. And my data doesn't fit an exact line. It's not actually equal. So what I have to do is I have to delete the equal sign, and I have to do the squiggle sign, which is next to the number 1 key on your keyboard. But it's also when you have to hold down the shift button and that little squiggle key, or tilde, I believe it's called, to get that symbol to appear. So y1 squiggle mx1 plus b. Or you can do how I did it. I just said y equals mx plus b, make it x1, y1. And I didn't do anything special. I just typed the number 1 after the variable, and your Desmos calculator knows to make it a subscript. It just automatically does it. It's so neat. And then don't forget to change the equal sign to the squiggle. That's super important because we're not coming up with a line that fits all of the data perfectly. It's an estimate of a best fit line. Okay, it's the best that we can get. So here's how we read. We get a lot of different things here. We get some statistics. It says residuals. It says parameters. So I want to go back to my presentation here for just a second. So when you see this screen, after you type in y1 squiggle mx1 plus b, these statistics, there's an r to the second power and there's an r. The r value is the correlation coefficient. Remember last week on our ed puzzle, we had to estimate our own r values? Yeah, this is the actual r value for a set of data. Now, this data is not the same as the one that we were looking at. So that's why this one is not showing a very strong correlation. This is about 0.6 or close to it if we rounded to the nearest tenth. And that would show a, kind of a weak positive correlation, kind of really close to that weak correlation, strong correlation border of about 0.7. So there's a correlation there. It's definitely positive because it's a positive number, but it's not real strong. The stronger it is, the closer to 1.0 it is. Then down below, we have M and we have B. Where have we seen that before? That's right. M is the slope of the line and B is the y-intercept of the line. So what we would have to do is write an equation that says y equals, and we type all of these numbers in there as the slope. So mx plus b, again with all of those numbers. And I think I have it here. There it is. So these are the exact same numbers. The green is the m from the previous screen, and this blue number is b from the previous screen. So y equals mx plus b is our model. If you wanted to graph that in Desmos, you would just type this into Desmos, and it would show you what your line looked like. And actually, I think after you do the linear regression piece, with the squiggle equation, I think it already does it for you. All right, so I want to go back here, just take a look at it. Oh yeah, it did. So notice I have my line drawn. I can see that my points are pretty close. That's your trend line. That's your line of best fit. And that's the equation that we could use to make different predictions. So I'm going to go ahead and just type that in, y equals, and then I typed in my slope value, put an x after it, and then you can put plus negative 1.21142, or I never like the double sign, so I just use the minus sign instead. And you'll notice that now I have this red line that overlaps that line of best fit that I had before from here. I can just hide that. If I hide them both, I don't see any of it. Okay, there's my regression line. And there's my regression line that I graphed on my own using the Desmos graphing calculator. All right, so that is how you can use Desmos graphing calculator to perform linear regression for you. All right, for our first problem today, we're going to use that Desmos graphing calculator to help us make the scatter plot of the data. We're going to do the linear regression to get a little practice with that funny looking equation. And then we'll also use that to make a prediction here at the end. So what we have here is a table that shows the lengths and corresponding ideal weights of sand sharks. So what we're going to do is we are going to start with making our scatter plot. So to review some of the steps, we're going to go to desmos.com. And you can see I still have data here from that baseball experiment with the strikes and the pitches. So I'm going to show you how to clear this quickly, and it's better than just going to delete all, because that's going to cause some problems. It might make the next table x2 y2, and then you have to use x2 y2 down here, and I think it just creates more problems than what you want. So I'd recommend going to the 3 bars and hit new blank graph. Okay, that'll clear everything. Okay, I would always recommend to do that when you start a new problem. So we want to enter a table, so we hit the add item button, we click table, and we're going to enter our data. So I'm going to go ahead and minimize this and see how I'm just kind of moving things around so I can see my data. It's a little trick you can use. Now, one thing that's different here is my table in Desmos is always going to go down. It's going to be a vertical table. My table on my presentation is a horizontal table. So I have to remember that the top row is my X, the bottom row is my Y. So when I type things in, 60 is my first X, 105 is my first Y. Okay, and again, you can just hit tab to move to the next item. So let's see, 64 for a length is 124 for the weight. 66 for a length is 131 for the weight. 68 is 139. A length of 70 is a weight of 149. A length of 72 is a weight of 158. The other thing I would strongly recommend is just do a real quick glance at all of your data. Make sure you didn't mistype anything. It is really, really easy to hit the wrong number on here, and it makes a big difference on your slope and your y-intercept later. So take the extra 10-15 seconds, just double check your data and make sure everything looks okay. All right, so my table looks fine. I don't see any of my data though, because my numbers are, pretty big compared to what I see here on my X and Y scales. So I hit this little zoom fit button, the little magnifying glass. It's going to zoom me out, and look at that. Those dots, they almost line up perfectly. So this is a very strong correlation here. And I want you to think about what type of correlation is it if my data looks like this? Hopefully you said positive, because you'd be right. It is a strong positive correlation. Strong because those dots really line up. They almost look like they form a line, like if you were plotting a line on a graph. But it also looks like it's very strong because they're close together. Okay, so the next thing we want to do is we want to actually get that line of fit drawn on here. And to do that, we perform that linear regression. So we go and we click in the second box. And do you remember what that equation looked like? It was kind of like y equals mx plus b. So if you want, you can start with that. Okay, and there's two things we have to change. We have to change the equal sign to the squiggle. Okay, so I'm going to delete or backspace on the equal sign, get rid of it. I'm going to hold down the shift key, and then I'm going to press the squiggle button, which is right next to the number 1. Okay, it's as far left as you can. It's right below the escape key on your keyboard. I wonder if it's actually even in here too somewhere. Right there. You can even get it on your keyboard too. So I opened up my on-screen keypad. I clicked A, B, C, and that's in the bottom row. It's this one right here. Okay, so if I actually use that, yep, there we go. It works. So you can do that as well if you're worried about finding it on your keyboard on your Chromebook. Okay, and you're like, wait a second, it's not giving me all those numbers that it did in the other video. And that's because we haven't identified that it's X1 from my table. So just after the X, you press 1, and notice it makes it a subscript, and Y1. So we have to change that also. There we go. Look at that. It gives you a nice line of fit. We can see how nicely it matches our green dots, our data. And then it gives us everything we need to know here. Our R value, not R squared. We don't really care about that. We care about just the regular R is 0.9992. That is extremely close to 1.0. So this is a very, very strong positive correlation. We can see that we have a slope of about 4.35714, and our y-intercept is actually negative 156.143. So we could type in our equation, just typing in those exact same numbers. So y equals, and then we put the m with the x after it. And I could put plus negative 156.143, but I know that when I add a negative, it's the same as subtracting. Okay, so if I take this other line away, I see that my line of best fit appears there on the screen. All right, so there's my equation. And minimize that for a second. Because now what we're going to do is we're going to predict the weight of a sand shark whose length is 75 inches. And I actually want to do this the other way. There we go. Now I can see my equation. Y equals 4.35714x minus 156.143. Make that a little smaller so it fits. All right, so my R value was 0.9992. Again, that's right here. My R equals, not R squared, but R equals my R value. And the last thing I have to do is figure out, well, what's the expected weight? So they're saying, what if the length is 75? So again, length was my X value. So what we're going to do is we're going to take this equation and we are going to replace the X with the number 75. So notice I took my equation, 75 inches is the length, that's my X value, so I replaced it with 75, And now I'm just going to use a calculator to do the math on this. It's going to tell me what the expected Y value or the weight of the shark would be. All right, so now I have to go back to my calculator. Actually, yeah, you know what? Let's use the Desmos calculator. So I want to show you how this works like a regular calculator too. But I need to see those numbers. 4.357. You know what? It's actually right here. 4.35714 times 75 inches. I get it in the parentheses. And then I have to subtract 156.143. So I'm just taking this part of the equation and I'm putting the length in for x, so 75 inches, and that will predict the approximate weight. So how I want to use this now is all of our weights up above were given in whole number values. So we are going to round our answer here to a whole number. Notice I did not round the slope. I did not round the y-intercept. Those are the exact values that I get from Desmos because I want my line to be exact as possible. The only time you round is at the very end in your final answer. Because I have a 6 after the decimal point, I would actually round this up to the nearest pound. It would be 171 pounds. I want to round this up to 171 pounds. I guess I'm assuming it's pounds. And that's linear regression on a set of data. We use the graphing calculator to make a scatter plot of the data. We use the graphing calculator to find the exact equation for the line of fit and the exact R value. And then we could use that equation to make a prediction. We took this 75 inches, plugged that in for X. We just did a little calculator solving, and that gave us our expected weight for a sand shark.